Question 1. What process occurs when an incoming photon with energy greater than the bandgap strikes a p-n junction? When an incident photon carries enough energy, it excites a valence electron into the conduction band, leaving a hole behind and creating a free electron-hole pair.
Question 2.
In a solar cell or photodiode, what forces photogenerated electrons and holes to separate and drift to opposite terminals? The strong built-in electric field across the depletion region separates the photogenerated carriers, sweeping them apart to generate a usable electric current.
Question 3.
Which parameter in the non-ideal diode equation accounts for carrier generation and recombination inside the depletion region? The ideality factor, typically between 1 and 2, scales the exponential response to account for non-ideal generation and recombination inside
Question
the
4.
depletion zone. What quantum phenomenon allows electrons to pass directly through a potential barrier in heavily doped Esaki diodes? In ultra-heavily doped junctions, the depletion layer is thin enough that electrons can horizontally tunnel straight through the barrier via quantum mechanics. Question 5. What unique current voltage feature is produced by quantum tunneling in a tunnel Esaki diode under low forward bias? As the forward voltage rises, the energy states misalign, causing the tunnel current to decrease. This creates a highly useful region
Question
of negative
6.
differential resistance. What is the operational term for a p-n junction optimized to emit light when forward biased via radiative recombination? Under forward bias, injected minority carriers recombine radiatively across a direct bandgap, releasing energy cleanly as light in a light-emitting
Question
diode.
7.
Why are direct bandgap materials like gallium arsenide preferred over silicon for manufacturing LEDs? Direct bandgap semiconductors allow electrons and holes to recombine without needing a momentum shift, yielding high-efficiency photon emission instead of waste heat. What non-ideal electrical effect causes the diode current to level off at exceptionally high forward voltages? At extreme forward currents, the small ohmic series resistance of the bulk semiconductor material begins to dominate, causing the current growth to become linear. Question 9. What type of recombination occurs when an electron and a hole recombine and pass the excess energy to a third free carrier? Auger recombination is a three-particle process where the energy released from a recombination is absorbed by another carrier, converting the energy into kinetic heat. Which model describes carrier recombination occurring through deep-level impurity traps within the forbidden bandgap? The Shockley-Reed-Hall model explains how crystal defects and intentional deep-level impurities act as stepping stones, speeding up non-radiative carrier recombination.